Get ready for physics 191. Roll that beautiful bean footage. And welcome to my reassessment number 2. Now, I am doing the reassessment on page 17, chapter 3, number 197. And we got mother loving physics on the mother loving plane. PG version, physics on the plane. Now, this is my work. Very neatly detailed. And I have a special guest, Majin Vegeta. And he's going to be representing my X vector. Alright, that's close. I'm going to get it. Let's see, what did I use? I used R2-D2 this time. Alright. So, step 1, got my free body diagram, as you should always have. And I took the liberty, I went ahead, figured everything out and labeled it, but this is my X. This is the total distance of the X traveled. And what I did was I put some imaginary lines there, to get this total distance. And, you know, that's at 30. And this is the entire distance of the trip. Now, let's go through the answers. Now, went ahead and drew my free body diagram. And I figured out the adjacent side of this triangle, which is 259.81 kilometers. And now I have that also with 600 kilometers. Now I got my total distance this way, which is 859.81. Okay. And let's see. I got 150 is the 150 kilometers is the Y coordinate this way. That's where I got this from. Opposite of that angle. And now we move on to this step. This step is how we get this big path, the straight line path. Okay, so you know you got your hypotenuse, you got your angle, and then you got your opposite over adjacent, whichever one you want to pick. And you just go ahead and plug it in to basically add these together, added these two vectors. That's how you got your X component. Just wanted to show that work. And now you do Pythagorean's theorem. A squared, B squared, C squared. Get it. Now, go ahead and do your square root. Got this huge number I'm not going to pronounce. Take too much time. And now you got the total distance. Got the total distance of C, which is the hypotenuse right here. Now we just go ahead and move on to B. Well, we got to figure out at what angle did the jetliner go if it was to go to a straight line path. That means that angle basically, come on, R2. There we go. The angle right there is basically going to be 9.89. You can round it up to 10, but to be precise, 9.89. Check that off. You got to just do that with inverse tangent. Do your total distance down over your total distance straight line. Now, note the switch on the answers. C. Total distance time this way is 1.5 hours. That's for your X. Total distance for your diagonal is, not total distance, total hours is 0.75 hours, which is approximately an hour. But it's going to come to the total straight line path of 2 hours and 2.25 hours. Not exactly sure the minutes on it. And that's if it flew at a constant velocity of 400 kilometers per hour. It's pretty fast. So if it was go from this point to this point, 400 kilometers per hour, that's how much it'll take. Now, correction, that's how much it'll take if it goes this way and that way. Now, if it went 400 kilometers per hour in the straight line right here, that's when you just go ahead, you put distance over velocity, and that equals 2.18 hours of direct travel. Once again, direct travel. That is this path. And this is my understanding of physics on the plane. Go ahead and get this standard. And I hope to see you guys soon on the next episode of Physics 191.